electžaIFD. Electricity Network Management System.
electžaIFD is an advanced embedded electricity network management system designed to monitor, control, and analyze up to 16 multifunction energy meters over a facility's electrical infrastructure. Its robust architecture supports local real-time monitoring via HMI and desktop applications, as well as secure IoT cloud integration via Ethernet or Wi-Fi with MQTT. Local data storage using a 2 GB microSD card ensures operational continuity and data resilience. Application area of electžaIFD: smart manufacturing, commercial buildings, energy utilities, data centers, renewable energy, farms and residential complexes. Capabilities of electžaIFD: monitor process automation, energy usage visibility, lighting, HVAC, overall building energy control, grid visualization, outage detection, remote reporting, continuous load tracking, alert management, distributed resource integration, grid synchronization, resident metering, and common utility monitoring.
System architecture of electžaIFD.
16 multifunction meters with Modbus measures electrical parameters. 4 Modbus interfaces, each connects 4 meters. 1 embedded controller with dual Ethernet, Wi-Fi, and SD card, which helps data aggregation and communication. 1 10.1-inch HMI display with Ethernet to have real-time visual control. A desktop application connected with Ethernet to view analytics and reporting. 1 microSD card with 2 GB volume for local data backup storage. System topology: 4 RS-485 ports, each connecting 4 meters, total 16. 2 LAN ports Ethernet. LAN 1 for local HMI/desktop. LAN 2 for Internet/MQTT cloud connectivity. Wi-Fi module for wireless MQTT publishing. microSD 2 GB card for on-device storage.
Hardware specifications of electžaIFD.
Embedded controller. Processor: embedded ARM/SoC with real-time clock/RTC, battery-backed. Memory: for data buffering, 7 days typical. Ports/interfaces: 4 RS-485, Modbus RTU. 2 Ethernet LAN RJ45, 10/100 megabits per second. Wi-Fi 802.11 BGN. 1 2 GB microSD slot. Power supply: 12 volts DC standard. Multifunction meters. Measurement: voltage, current, power, power factor, frequency, energy kilowatt hours. Communication: Modbus RTU on RS-485, addresses 1 to 16. Installation: daisy chained in 4 groups per RS-485 line. HMI panel. Display: 10.1-inch LCD touchscreen, 1280 by 800 pixels. Network: Ethernet LAN 1. Mounting: panel mount. Desktop application. Platform: Windows 10/11. Connectivity: via facility LAN 1. User features: real-time display, time series plots, reports. microSD card. Capacity: 2 GB. Storage, data and event logs, backup of meter readings and events.
Communication architecture of electžaIFD.
Local data flow, LAN 1. RS-485 ports poll each meter group, configurable intervals, for example every 5 seconds per meter. Data aggregated by the controller, timestamped via RTC. Real-time data stream to HMI display with operator interface and desktop applicatio with advanced features, analytics. Internet/cloud connectivity, LAN 2 and Wi-Fi. LAN 2 connects to external internet via gateway router. Supports MQTT for cloud integration, remote dashboards. Wi-Fi: alternate or supplementary path for MQTT connection, suitable for wireless network environments. Data storage. All polled receive data logged to 2 GB microSD card for reliability and recovery. In case of outages, disconnects, data is buffered and uploaded once connectivity resumes.
Software features of electžaIFD.
Embedded firmware. Cyclical polling of RS485 ports meters addressing collision avoidance. Comprehensive error handling and retrieve. Timestamps via RTC. Data packet construction for real-time streaming and/or MQTT publishing. Data logging to microSD. HMI software. Live overview of all 16 meters. Dashboard gauges and status indicators. Alerts for communication errors or threshold violations. User management, role-based as needed. Desktop application. Live monitoring, grid table view of meters and readings. Charts, time series/overlay graphs, by meter group all. Reporting custom daily, weekly, monthly, CSV PDF export. User management roles, viewer, operator, admin, credentials, access logs. MQTT integration. Publishes data packets, configurable frequency, to broker via LAN, 2 or Wi-Fi. Cloud server dashboard compatibility for monitoring, analytics or automation.
Installation and configuration of electžaIFD.
Hardware setup. Connect each set of 4 meters to designated RS485 ports. Terminate RS485 lines with appropriate resistors. Assign unique Modbus addresses per meter, 1 to 16. Insert and verify microSD card functionality. Connect LAN 1 to facility network for HMI/desktop. Connect LAN 2 to secure gateway router for internet/MQTT. Configure and verify Wi-Fi if needed for MQTT cloud publishing. Software configuration. Set Modbus addresses and polling intervals via desktop app or local utility. Assign static or DHCP IPs for both LANs. Wi-Fi credentials configured via app/HMI. MQTT broker settings entered as per cloud/remote dashboard requirements. User role and credentials set via desktop application.
Operational modes of electžaIFD.
Routine operation. HMI presents real-time diagnostics and quick views. Desktop software enables deeper analysis, report generation. MQTT streams key data to remote cloud platforms if configured. Error handling and data recovery. RS485/network faults flagged on HMI and desktop. On network failure, data buffered and/or logged to SD until link recovers.
Benefits of electžaIFD.
Benefits across application areas. Cost reduction through real-time alerts and actionable insights. Improved power reliability by detecting and addressing faults proactively. Regulatory compliance simplifies auditing and reporting requirements. Seamless data integration enables advanced analytics and smart grid integration through MQTT cloud connectivity. electžaIFD is well suited for deployment in any sector where reliable, transparent, and integrable electricity network management is essential, ranging from utility substations and corporate campuses to factories, data centers, and renewable energy deployments.
Maintenance of electžaIFD.
Security. Password protection and access levels in desktop and HMI. Local network isolation between LAN 1, internal ops, and LAN 2, internet cloud. Data encryption for MQTT messages where supported. Audit/log for configuration changes. Maintenance and updates. Periodic RTC validation and sync via desktop or NTP. Firmware upgrade facility, local or remote. Data log backup export via microSD or desktop. Diagnostics for meter health and comms integrity.
Frequently asked questions.
FAQ and support. Question. What if the internet or network connection is lost? Answer. electžaIFD buffers, logs all data locally to microSD, and retransmits when connectivity is restored. Question. Can more than 16 meters be added? Answer. No, each unit supports up to 16. Add additional electžaIFD units for expansion. Question. How frequently is data updated? Answer. Default is every 5 seconds per meter, adjustable in configuration. Question. Is data secure when publishing to the cloud? Answer. Yes, data isolation and encryption best practices are recommended for MQTT cloud deployment.
Thank you, friends. For more details, please contact us through our email ion@ionix.com.